In this chapter, we'll see what is a chemical equation, what do we learn from a chemical equation, and how to properly write a balanced chemical equation. So by the end of this chapter, you must be able to interpret chemical equation with state symbols. What are state symbols? How do we know them? How do we write them? Or what is their meaning actually? And you must be able to write down a balanced chemical equation with state symbols. Alright, so from now on, after this topic, whenever you'll write a chemical equation, you'll have to make sure it is balanced and you have to make sure that you write the state symbols with it. Alright, so let's take an example of natural gas that we use in our stoves for cooking. Natural gas is basically, it's a methane gas, and methane is CH4 in presence of oxygen, and we get carbon dioxide in water. This is the word equation for it. Methane burns in presence of oxygen and it gives carbon dioxide and water. Alright, methane and oxygen burn together. What do we get as a result? We get carbon dioxide and water, and obviously energy. So, if you want to represent the same word equation in a chemical equation form, then you'll simply write down the chemical formulas for all the reactants and products. So methane is CH4 and it is a gas. It burns with oxygen. Oxygen is O2 and it is also a gas. And carbon dioxide is CO2, which is also a gas. And then water vapors are produced, that is why it's gaseous. And water is H2O. Alright, so these are the things that react and what is being produced. You see that I have added 2 over here and 2 over here. This is to balance a chemical equation. You will soon be able to understand that where do these words or these numbers come from and how you can add these numbers yourself to balance a chemical equation. Let's move on. Photosynthesis, a very essential chemical reaction which basically provides energy for almost everything in the world. In presence of sunlight, plants convert carbon dioxide into glucose, and obviously they use water from the soil as well. So if you write the word equation for the reaction of photosynthesis, then it is something like this. Carbon dioxide, it reacts with water in presence of sunlight and it reacts to give glucose and oxygen gas. A chemical reaction or a chemical equation for this reaction would be carbon dioxide, CO2, which is gas, it reacts with water, H2O, which is a liquid, and it gives glucose. Glucose is C6H12O6 and it gives oxygen. So this is a chemical equation for this. Again, you see here that I've added 6 over here, 6 over here, and 6 over here, which means that 6 molecules of carbon dioxide, they react with 6 molecules of water and they give 1 molecule. Because there is no number written over here, written in front of chemical formula of glucose, it automatically means there is 1. Alright, so 6 molecules of carbon dioxide react with 6 molecules of water to give 1 molecule of glucose and 6 molecules of oxygen. This is what a balanced chemical equation looks like. Again, we will soon see how or why have we written 6 over here and how can we add any numbers to balance the chemical equation. But again, right now you must have an idea that we add certain numbers in front of the chemical formula of molecules so that the equation is somehow balanced. How do we add that? Let's see. A chemical equation shows reactants and products and their relative amount. This relative amount is actually represented by the numbers that are added over here. Relative amount means how much of their quantity is required. Now we know that 6 molecules of carbon dioxide are required to react with 6 molecules of water, and then we'll obtain 1 molecule of glucose and 6 molecules of oxygen. That is the relative quantity. CO2 to H2O and glucose to oxygen, the ratio or the relation is 6:6 and 1:6. This is what relative amount means. Alright, this is the amount of each reactant and product that you need or that you get for this reaction of photosynthesis to take place. Number two, physical states of reactants and products. A chemical equation also shows you that carbon dioxide is gaseous, water is liquid, water from the soil, and glucose is aqueous, dissolved in water. Aqueous means dissolved in water, and oxygen is gas. It's in gaseous state. This is the oxygen that we get for our respiration. So let's see how can we balance a chemical equation, or how do we balance a chemical equation? Where do these numbers come from? How do we know that we need to add 6 over here and 1 over here and 6 over here and 6 over here? Similarly, this is nothing written in front, that means 1. And where how do we know we have to write 2 over here, and there is again nothing written, which means 1, and again 2 over here? So how do we know that? How can we balance a chemical equation? So here are a few steps. Before I go on, you must realize that balancing is same as we do in maths. We write an equation in mathematics, a mathematical equation. For example, 2 is equal to 1 plus 1. So both right hand side and left hand side of this equation are equal. So this equation is a balanced equation. This is a balanced mathematical equation because right hand side is equal to the left hand side. If it was 2 is equal to 1, then obviously this is not true. This is actually not possible. 2 can never be equal to 1. So this is an unbalanced equation. You need to add 1 more over here, only then the equation will be balanced. Alright, or you need to multiply this 1 by 2, and then the equation will be balanced. Then the equality will hold. So same is the case with the chemical equations. The chemical equations must also be balanced. Chemical equations must also be equal. Their right hand side and their left hand side must be equal. This arrow that is in between the reactants and products, this is in a way equal to the equality symbol. Alright, so right hand side and left hand side, they must be satisfied, they must be balanced. Similarly, this mathematical equation 3a plus 2b is equal to 6ab. Now this is also equal. The equality sign holds. This is true. We call this a balanced mathematical equation. And when we write the chemical equations, in the same way, they must also be balanced. How do we do that? Let's see. A chemical equation must always be balanced. It must contain equal number of atoms of each element on both sides of the equation. What does it means to balance a chemical equation? It means that it must contain equal number of atoms of each element. For example, if we have, just a second, there is a little lag. For example, if we have CH4 plus O2 and it gives us CO2 and H2O, if we talk about this equation, then it must be having equal number of atoms of each element on both sides. For example, if there is one carbon, then the number of carbons on both sides of equation must be equal. There is one carbon on the left hand side and there is one carbon on the right hand side. Number of carbons is okay, it is balanced. But if you see number of hydrogens, it is 4 on the left hand side and it is 2 on the right hand side. So it is not balanced. And this rule says that a balanced chemical equation must contain equal number of atoms of each element on both sides of the equation. All the elements, whether it is carbon, whether it is hydrogen, or whether it is oxygen, all elements, their number must be equal on both sides. So this equation is not balanced. Similarly, there are two oxygens over here and there are 2 plus 1. 3 oxygens over here. Number of oxygens is also not balanced. Alright, so there is a discrepancy. How do we tackle that? How do we get this right? How do we balance it? Let's see the steps. So I hope it is making sense. I hope you now understand that all the elements, atoms of all the elements, they must be equal on both sides of the equation. On both sides of equation, number of carbons must be equal. On both sides of equation, number of hydrogens must be equal. On both sides of equation, number of oxygens must be equal as well. All the elements that are present in a chemical equation, they must be equal on both sides of the chemical equation. For example, if there are 4 hydrogens over here, then how come they have reduced to 2? Where did the 2 other hydrogens go? And similarly, obviously they cannot be lost in the surroundings. Law of conservation of mass says it cannot be created nor destroyed. If there are 4 hydrogens over here, and there has to be 4 hydrogens on this side as well. They cannot just disappear into the air. Similarly, if there are 2 oxygens over here, then how come this side of equation has 3 oxygens, 2 over here and 1 over here? A total of 3 oxygens. How is it possible? Where does the other oxygen come from? It cannot just appear itself like a magic. Magic doesn't happen in chemistry. It is all science, it is all mathematical calculations, and that is why we need to balance a chemical equation so that we understand what is actually happening. So here are the steps. Let's talk about this equation. Hydrogen and oxygen, they react to give water. Left hand side is for the reactants. If you see, the reactants are written on the left hand side of the equation. If we are talking about this chemical equation, then we have it is separated by this arrow, and the elements that are on the left hand side of this arrow are the reactants, and the elements which are on the right hand side of this arrow, they are the products. Products are written on the right hand side of the equation. Reactants are written on the left side of the equation. And then these numbers, the chemical equation is balanced by adding a number in front of a chemical formula. For example, if we want to balance out hydrogens, then we'll simply add a number, which we'll soon know how do we find out that number. So we'll always add that number in front of this chemical formula of hydrogen. If we want to balance out oxygen, although oxygens are already balanced, then we need to add a number over here. If there is no number, we can assume that it is 1. Similarly, if we want to balance out this chemical formula, anything in this, then we will always add a number in front of it. We cannot add a number over here in front of oxygen. We cannot change this chemical formula. If we add a number over here, it will change the chemical formula. If we add or a 2 over here, then it will turn water H2O into H2O2, which is hydrogen peroxide, and not which is something you do not want to drink. This is hydrogen peroxide. it changes the chemical formula, it changes the element, it changes the compound itself if you add a number in the subscript. So that is why you can only add you can only add numbers in front of the chemical formula. Alright, you cannot add numbers over here in the subscript. So this arrow means they react to form, these reactants, they react to form these products. Alright, and these are then the state symbols. It is liquid over here, gaseous over here, and gaseous over here. State symbol shows the physical state of each reactant and product at the time of that reaction. S is for solid, L is for liquid, G is for gases, A is for aqueous solutions. Alright, AQ is for aqueous solutions. So how do we balance this? What are the steps in balancing a chemical equation? Please have a look. Steps in writing a balanced chemical equation. Number one, chemical formula and chemical equation. You must need to write down the chemical equation. You cannot balance the word equation. So from a word equation, you will write down a chemical equation, which is this. Hydrogen plus oxygen, they react to form water. I have just shown you this diagrammatical representation of what is actually happening. We have a hydrogen molecule which has two atoms of hydrogens, and we have an oxygen molecule which has two atoms of oxygen, and we have a water molecule which has one atom of oxygen and two atoms of hydrogens. Alright, so where did the other hydrogen atom go? We had two hydrogen atoms over here, and now we have one. How is it possible? So the thing is, it doesn't go anywhere. We'll just see what actually happens. So rule number 2, check the number of atoms of each element in the formula on both sides of the equation. If there is a discrepancy in the amount of atoms of any element, go to step 3. We have already found that discrepancy. How do we calculate that, or how do we do it mathematically? Or because this is a very simple equation, only two atoms or two elements are involved. So we were able to figure this out very quickly. But you must understand the right process. You must understand the right way of identifying the difference in the amount of atoms of each element. So what do is, you make this table, you write down the elements of the left hand side over here and the right hand side, and then you list down all the elements that are present in the equation. So hydrogens, let's talk about hydrogens first. On the left hand side of the equation, we have two hydrogens over here, H2. Alright, there is a molecule of hydrogen, and in each molecule there are two hydrogen atoms. So we need to write down the number of atoms, not the molecules over here. So there are two hydrogen atoms, and oxygen, there are two oxygen atoms as well. There is one molecule of oxygen written which has two oxygens. Alright, this 2 shows there are two oxygen atoms in one molecule of oxygen. So on the left hand side we have two hydrogens and we have two oxygens, whereas on the right hand side we have two hydrogens. The subscript shows that it is with hydrogen. Alright, it is not with oxygen, it is only with hydrogen. So we have two hydrogens on the right hand side and we have one oxygen on the right hand side. If there is no subscript, it means 1. Alright, so we have one oxygen on the right hand side. You see the problem over here? Hydrogens are balanced. There is no issue with hydrogens. They are equal, but we have a difference in number of oxygens. Where did the other oxygen go? What do? We go to step 3. What is step 3? Balance the equation by adding appropriate number in front of chemical formula. You always add the appropriate number in front of the chemical formula. You add 2 over here, you add 3 over here, 4 over here, 5, 6, whatever you want. You always add it in front of the chemical formula You always add it over here. You never add something over here, or you never change this. You never change this subscript. Alright, this is the part of chemical equation. Once you have written the chemical equation, you do not change subscripts. You can only change the number over here. You only have this liberty that you can add, or you can any number, you can change any number that you have in front of the chemical formula. Alright, never change the formula of a substance. If you add 2 over here, I've already told you, it changes the formula. It is not water anymore. It is hydrogen peroxide. Alright, similarly, if you add O, you change it to 3, then it is not oxygen anymore. It is ozone. Okay, so it is not advised, or it is not allowed, that you change the subscripts once the chemical equation is written. Alright, so what do? You add the appropriate number in front of the chemical formula. Let's see. We have 2 oxygens over here. Now we can add any number that will make it balanced. What do? We multiply this by 2. Alright, we need one more oxygen over here. So we can multiply this by 2 so that it becomes 2 as well. So now both sides have 2 oxygens. Alright, let's try putting this in a chemical equation. As I told you, you can only add a number in front of this chemical formula. If you add 2 over here, then this means that now we have 2 water molecules. This 2 is added with both hydrogen and with oxygen as well. This 2 is added with both of these elements, both of the types of atoms that are involved. But now we have a problem again. Although the number of oxygens is now balanced, we had 2 oxygens on the left hand side, and now this 2 multiplied by 1, we have 2 times 1 equals to 2 oxygen atoms now. But again, this 2 is also being multiplied by hydrogens. We already had 2 hydrogens. Now we have multiplied it by 2. We now have a total of 4 hydrogens. Alright, so this is also multiplied. Automatically, we have 4 hydrogens on the right hand side. Now what do? We only have 2 hydrogens on the left hand side. Now we need to make this 4 as well. You can again multiply this by 2. Now this will also become 4. Now do this over here. Now because you need to multiply this by 2, you need to add 2 more oxygens. So you can do 2 over here. Now 2 multiplied by 2, 2 multiplied by 2 is equal to 4 hydrogens. Now the number of hydrogens are also balanced. Number of oxygens are also balanced. So this is the equation that we have made. We have written 2 over here, and we have not written anything over here. It remains 1, and then it gives us 2 water molecules. Now if you see, 2 times 2 equals 4 hydrogens, and 2 times 2 equals 4 hydrogens. Oops. Similarly, 1 times 2, you do not need to write 1 over here. It is understood that if nothing is written, then there has to be 1. So 1 times 2 equals 2 oxygens, and 2 times 1, if there is nothing in the subscript, it means 1. Alright, and 2 times 1 equals 2 oxygens. So number of oxygens on the right hand side is equal to the number of oxygens on the left hand side. Similarly, number of hydrogens on the left hand side is equal, number of hydrogens on the left hand side is equal to the number of hydrogens on the right hand side. Alright, so number of hydrogens are balanced, oxygens are balanced, and hence our equation is now balanced. Alright, next step, you add the state symbols to indicate the physical state of each reactant and product. Alright, now this is the equation. 2H2 plus O2, it gives 2H2O. Now you add the state symbols. Hydrogens, we know it from the bonding and structures, it is a gas. Oxygen, it is also a gas. And H2O, it is liquid at room temperature and pressure. So that is how you balance a chemical equation. I'll quickly revise the steps. In the first step, you need to write down a chemical equation, and then you need to see what is the discrepancy in number of atoms of each element, and then you need to do some mental maths. You need to add or you need to multiply the elements with a few numbers, and then you need to adjust all the atoms of each element. And finally, when you're sure that all the elements are balanced, all the atoms of all the elements are same on both right hand side and left hand side of the equation, then you will add the state symbols. That's it. In the next video, we'll do a few more examples of, and we'll do a little more practice of how to balance a chemical equation.